This video demonstrates the use of PV curves, one of the functions available in the Transmission Network Tools toolbox. The project should have Study Case 05 Transmission Network Tools PV active. PV curves are a useful tool for assessing the performance of a network under conditions of increased load, indicating how much the demand can be scaled and where the critical points in the network are. For critical bus bars, a plot can then be created of voltage against power. We'll first run a load flow to check that there's a valid base case. In this example, automatic tapping of transformers and shunts will not be enabled. The selected balancing option is Distributed Slack by Synchronous Generators. We now run the load flow. In the Transmission Network Tools toolbox, this icon is used to run the PV curves calculation. It's possible to scale loads across the whole network or select a set of loads to be scaled. It's also possible to record results for all bus bars or just a selection. In this case, we're interested in the effect of scaling loads in the southeast of the network, so these loads have been selected. Results will be recorded for all the transmission level bus bars in the network. We click on Execute to start the calculation. In the output window, we can see the critical demand to which the loads have been scaled and the critical bus bar is shown. The critical bus bar is the one where the voltage is most sensitive to the change in active power in the last successful iteration of the calculation. Although only one bus bar is reported, in fact all bus bars in substation SE01 are equally critical as they are all interconnected. A PV curve can now be plotted using this icon. By default, a PV curve is plotted just for the critical bus bar. But here we have selected the 7 transmission level bus bars in the southeast. The curves are created. Here you can see how some of the bus bars have identical voltages. The fact that the bus bars in substation SE01 are the critical bus bars is indicated by the gradient of the curve at the last iteration. Returning to the PV curves calculation, it can be seen that it's also possible to consider contingencies when running the PV analysis. We follow the link to the contingency analysis command where the contingencies to be considered are specified. We've selected all transmission level bus bar faults in the southeast. Now the PV curves calculation can be repeated with the contingencies being considered. In the output window, the critical bus bar is shown for the base case and each contingency. Overall, a bus bar fault on bus bar BB in substation SE02 is the most critical case. And the critical bus bar is bus bar BB1 in substation SE03. From the various plot options, we can create a PV curve for the critical bus bar in each contingency analysis case. This gives us a good overview of the voltage stability of this area.